In these lessons, we will discover two hooks provided by React 3 Fiber that are very useful. We have use3 and useFrame. Let's start by use3. It gives us access to a lot of useful information about our current project, as the renderer, the scene, the viewport, the camera, and so on. I won't go through each property in this lesson because when we will encounter new ones during this whole course, I will explain to them as they appear. But I recommend you to have a look at the documentation and to discover all the different ones that can be useful in your project. Let's see how to use use3. Const, we get an object so we can destructurate it. Let's get the camera from use3. And it comes from React 3 Fiber. By doing this, we have access to the camera inside our React component. But this is not the best way to use use3, because by doing this, any change in the state of use3 will cause a re-render of our component and we will get the updated value of camera, even if camera didn't change. Instead, we can have a callback function. We pass the state and we return state.camera. So here we don't get an object anymore, we just get the camera. By doing this instead, only when the camera changes, the component will be re-rendered. Because you don't have to trust me on word every time, let's create an update FOV method and try to update it on our camera. So we'll get the field of view here. What we will do is camera.fov will be equal to the new field of view. And when we do it, we need to call this method camera.updateProjectionMatrix. To tell Three.js it has to update it. Then we will use controls from Leva. Instead of directly passing an object, we can pass a string. It will create a folder with the name. So let's add field of view here and let's create different button. So button from Leva, update field of view of 20. And we will do 4 different ones. We'll have the normal, the big, and the huge. The values, let's use 42, 60, and 110. Now, if you look on the top right, we have our buttons, but we also have that label, field of view, that we can toggle on and off. So if we change it, and the small is getting our closer, and the more it's big, the more we see. Time to talk about useFrame. First, what you need to understand is that Three.js is based on a render loop. What it means is what we see on the screen is the result of a loop that render every frame our scene. As a video is a succession of images, a 3D scene is a succession of frames. And useFrame is a hook that allows us to execute code on every frame. Let's see how it works. useFrame. It takes a callback function, and the 2 parameters it gets is the state. So it's the same one than with use3. And the delta time, which is the time elapsed between the previous frame. That variable is very useful when you want to create animation that are not related to the frame rate of your project. So you have the exact same visual animation, whatever the speed and the performance are. You wouldn't like that the speed of a character is based on the performance of the computer. You want it maybe to lag and jump, but you want the same exact result. So let's try to play a bit with it. Let's create a reference on our cube, so our mesh here. Let's declare it with useRef. And let's use other controls. We'll group it into a speed folder. And we'll declare speed with a value of 0 by default, minimum to -12 and maximum of 12. So it can go both ways. We need to get it from our use controls. And in our use frame, so every frame it will execute that function here. We will do on the rotation of our cube on the y-axis, we will increase it by the speed multiplied by delta time. So the frame rate won't impact the speed. And because here we are not using the first parameter, what you can do is use underscore the name of a variable So it just ignore and it understand that you are not using it. But it's up to you. You can just leave it, but it's just you will get a warning. Is declared, but value is never read. So instead, use the underscore. Now we have the speed folder with its slider. It's at 0, so nothing is happening. But we can impact the speed going very fast to very slow and change the rotation side. So it looks pretty cool. Let's remember a few things about useFrame. So this function is called on every frame. So if you have 60 frames per second, which is maybe what you tend to want to have, this function here will be called 60 times per second, which is a lot. Knowing that, you want your function to be very well optimized and don't do heavy computations inside. Avoid object instantiation inside and prefer to reuse variables and access them only from the useFrame. Also avoid to do setState with different values. If it's only changing an animation, it's okay. But if you're changing the position and expect to re-render the position of the cube, it will be very laggy and cause issues. But don't worry, we will talk more about optimization in the dedicated lesson.